بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على رسول الله وصحبه وسلم. مرحبا بكم. We welcome everyone attending this workshop and we thank Insight for having this presentation, and also welcome my colleagues from the Department of Meteorology, Mansour Almazroui, and also Jam'a from GCC. My talk is going to be about climatological feature of dust storms activity of the Arabian Peninsula. But this is just only the starting of the thing. We have what is called sources of dust storms. We have also need to know the thing that is important for us. The climate of the Arabian Peninsula is influenced by two atmospheric systems, Mediterranean and the Indian Ocean circulation. So this interaction will give us a lot of activity for the dust storm and for weather in Saudi Arabia or in the Arabian Peninsula as a whole. So this really has to be taken in consideration when we talk about dust storm. Dust storm doesn't come just only from the north, it should be coming from the south, or should be coming from other activities. The thing that we would like to say, this is one of the causes of severe environmental issues. This is why dust storm is really very important for health, for every aspect of life. This is how we really want to study the dust storm. The peninsula, in addition, is location, is significant source of dust storm between the world largest. But now, you know, the Arabian Peninsula is really located over the subtropics, and really we have the Sahara Desert, we have the Arabian Desert, and we have the China, but this system as a whole is full of dust storm. This is what we would like to talk about in the discussion, why we have northwestern central region, we have northeast region, we have southwestern central region. This is going to be discussed in the presentation. I'm going to talk to you about later. Now, we'll go forward. This is just only to show you how the dust storm is being shown in Saudi Arabia. It's really very big. And this is why the Saudi Arabia has announced the dust storm center. And we have Brother Jam'a as a director for this center. We really need it because we have a big problem that really not affecting us, affecting aviation, affecting schools, and affecting many things. And due to climate change, this dust storm will increase. This is why the Jam'an, we should also couple your work with the climate change center. You alone are going to be working. You should also work with the climate change center that is being initiated by the NCM. So this is also a big message to Dr. Ayman. These two centers should work together. This dust storm really has a big health environment on the society and many things. We'll go forward. As we talk about the sources, we already talked about it in many slides before. We talked sources and we talk about the sources. Even Ayman talked at the beginning and then Ahmed talked about the sources. We know the sources. But what is the important thing actually for us is that this is the north. The Sahara, the Syrian, and then this region, as well the eastern region, and the Rub' al-Khali. And definitely you know the Khamasin region, you understand this together. Why I'm talking green, blue, and white, and this is going to be discussed later. Now, this is what is called, in fact, the frontal system. So these are the issues where these fronts or extended front will have big cases of dust storms. Among these three pictures, there is one picture of it was really having big events of dust storms. Which one do you think? Is it the left one or the right one or the right one? Which one is going to be more having dust storms? Who can say? It's a quiz now. Can you tell me? I tell you. This one is really having big issues. This is, by the way, is called the stem grain. You know the stem grain? In Arabic, what they call it? Sabakat array. You know, when it is happened, it happened in 2011, and it happened before a few days ago over Kuwait, over Iraq, and it happened many events. There isn't a big event actually of dust storm was actually in this case. This one, in fact. I'm going to talk to you later on when it will be big, active, in which month. This is going to be discussed later. Now we have the sources actually. You know, if you want to have dust storms, you have to have two things. Soil type, you have to have the wind speed. The triggering wind speed for the top one is 11 meters per second. But this one is 6 meters per second. Why? There must be a reason. What is the reason? Who can tell? Who's actually the center of dust? What is the reason? Actually, this one is related to the soil type. The soil type here is clay. And this one is actually fine sand. So anything related to a few wind, it can blow up. But this one is really take a long time because it has at least 11 meters per second. This one is 10 meters per second. Now this is the picture of you know, it is from Islam and the Mazrou'i in 2012. Islam and Mazrou'i is very famous guy, Mansour Islam. He's now in America. He was in the department. He lived, and we actually would like to bring him back. So what is this actually? This is the source of concentration of dust storms in the region. And you can see the most black region is this is like the source of dust. This is like the concentration of dust in this region, but the source of it really is going to be the black. So this is really very important in terms of showing the dust, how they are actually in the region. Now we're going to talk about some observational cases. طيب يا شباب هذه صورة بتوريكم عن number of days of dust storm. This is actually from a study by العلمية. He's a student with us before with Dr. He did a PhD thesis of a dust storm where he showed from 1983 to 2013. As you can see that the big sources of dust is really concentrated over that northeast. Where Jama'an, this should have aeronet data, this region. And also you can see more focus of dust really over this region and this region too. So these are three regions where maybe aeronet station can be installed in this region. Now, this is what we call, this is part of the study in fact, that we have collected the data from different stations around the Arabian Peninsula. Including Kuwait, including Oman, including Bahrain, and including other regions. But the data that we took is not daily. The most important thing, we have taken hourly data. And then we made like a software or application where we have figured the sources of dust, and then we did actually the BCA. You know BCA? Principal Component Analysis. We categorize this region. And we found, in fact, in this there are three regions, which is Bernard BC1, and then BC2, the red one, and then the third one is this region. So this region was like, we talk, a key station. Key station is which is the station which represents this region. And we talk a station where represents this region, and this one is Rafah, and this one is Hassan, and then here Jeddah. And we studied in particular, well, this is, for example, the station where northwest central, and then this is Hassan northeast, and this is southern and western coastal area. So you can see here different stations where are categorized with the same characteristics. Although it is in different location, but it has different similar characteristics. But what did we have here, in fact, as we can tell to what did show that the peak is where actually now you see it. Can you tell me? The peak, which month is it? April. Can you see April? And what does it mean? Say the other one is say the peak is where? March and May. And the peak here is March. But what does it mean? It means that spring is really the season of the heavy dust storm in the Arabian Peninsula. Whether it is March, whether it's April, it is May, this is all spring. Now you can see here, this is a good graph actually to show you. But what is I meant for showing it when all shows the peak of dust storm. But one thing here, you can see this one is what decreasing in April. What happened here? There we needed a study. We needed to study why it's the drop in April and May, in April in this one. So we have to study carefully. But you can see it is all peaking in spring. And this is really very important to do. And this is actually, this one, the dashed line actually is the average of all the regions, the black one. So this has to be really more study to be done in the study of the dust storm. But we don't study daily, we have to study hourly, because this is huge. Now you can see, this is the trend actually, but you can see here that almost there is no trend in fact here. Rafah has no trend. Jeddah is shown a little slight decrease, but no trend in fact. The only station which shows a special trend is actually this one, Al-Hassan. But also just about to be significant. So what we can say here that this is not that significant, but has to do by the way that more studies needed in the region. Not just only in this station, we have to study all the region, and this is part of the center of the dust. The other thing is actually when it happened, the dust storms. In which season? And what is the largest activity that can contribute to dust storm? We have two large scale phenomena. North Atlantic Oscillation, and you have means too. You have La Nina and you have what? El Nino. You know La Nina is related to what? Dry. And the Nino dry related to what? Warm and wet. So what happened, in fact, is that the more dust is happening when it is dry. La Nina, when is it La Nina, when is it a dry case. And bits of Nino is related to also the dry and the dry and not actually rain over the region. So what is really shown that it is more dust over when it is positive in air and La Nina. But what will happen if it is both? Positive in air and La Nina together. So it should be more extreme dust storms. Now here is a simulation of dust storm on 17 January 2019. So this is actually the thing that we didn't say. Maybe this is actually gap. What's it called? Gap. You can see it is attending rain for a case from Africa and attending to Arabian Peninsula. This is the map. And you can see here the concentration of dust storm on the region, and this is on that day, where you can see it is more dust than the black one. And this is going to show the propagation of the dust. This is before the dust, in fact. الله الرحمن الرحيم. معليش سامحونا. يعني هنا نوريكم كيف يا شباب اللي هو vertical cross section of dust storm on different time, because you see the head, it is showing the cross section, and this is before the event, and this is during the event, and here it is after the event. But what you can see here, this is actually showing during the event what will happen. That this is on the day of the event, this is the region, and here after the event. You can see there is a drop in the temperature and humidity in this region, and afterward there is homogeneity of the data. And here it shows that the temperature and humidity for that region, you can see it is dropping here. This region, the 03, which is UTC time, so it's going to be dropped. And this is actually during the dust storm case. It is, you have strong wind. Can you see the strong wind on the left side? And then it is normal. You see the case is getting normal, and this is really the dust storm case, and here it is the no case. And also this is about rainfall, temperature and pressure. Wind speed and the pressure, there will be increase and decrease gradually. And here the time of dust, the time of what is called AUD, where it is, you know, the dust is 0.05 is 1, and then this 1. And this is dust on 1.4, and the dust 3 is 2.4, and then 4 is 4.5. So what does this mean? The concentration of this AUD is really on 3 and 4. So it is a bit heavy. And here dust 5 is really nothing. So more simulation is really needed for the AUD. And this is why we need, once we do on the climate models, we have to run the AUD stuff. So this is the concluded remark actually, that April is the peak of the DCA. And we have to think about the DCA in different actions. Further required the study to focus on simulation of dust storm event, simulation of deadening to large scale phenomena. This has to be done, by the way, in the future. And also we do the projection of dust storm for the cases of the dust. طيب. Let's do the past. Yeah, this is actually what we do. With that, we show that the 40% of aerosols are actually in the lower layer of the atmosphere. This is and also we talk about the main source. Now, what is really we need to expand research to talk. Listen here. This is really the element we need to have actually ground-based aerial data, and also. We need access to satellite-based remote sensing data using such clips. And also we need to use the satellite-based piece of data, for example, MODIS, MCR, and OMI. And also we need actually to work on the artificial intelligence and machine learning. Now the research is not only modeling, it's also machine learning and artificial intelligence. And even in the university now are thinking about using the machine learning and the artificial intelligence. Now, what actually I'm doing, this is also for your good knowledge, we have Nabila here from CAUS. I'm working with her on different topics. So one of them is really the impact of spatial temporal variability of dust storm extreme impacting the solar energy. So this is one of the studies that we are doing. It actually, we have different time. We have the meeting on most of the time on Zoom. This is very good. So really working with this, and we are planning to do different work. The other thing also, I'm working with China. So working with China in terms of AUD. MODIS and using MCR or Eclipso and using all this data for some work that we do now in this work, and we are using the supercomputer, and we are using different supercomputers in the world, not just only as this supercomputer. Now also we have collaboration with Sydney University of Australia for machine learning also. So what is the limitation in actually is really limitation of the data. So we have distribution of the sparse aerosol sessions. Really, we have a big problem of the stations around the Arabian Peninsula, around the whole Saudi Arabia and the region. In fact, even meteorological data is really very sparse. What do you think about the data of AED or air quality? It's really very sparse. So really, this is an area where we need to have regional gathering for this, and maybe GCC guys can really try to support the researcher of obtaining this data. So this limitation is really very important, and particularly the air quality data. So what is the recommendation is really to have more real-time air quality stations across the countries, and also developing platform and tools which can utilize the ground-based measurements. So this one is going to be helping, in fact, different people who are having work on dust storms. And the big problem is really having, is even all the research, not enough from now, for a long time, is accessibility to this data. The accessibility of this data is really big issue. So this is my presentation. I'm sorry for having all these stories.
Thank you very much, Professor Mansour, for a very rich and nice, emotional, and spectacular presentation. I'm quite sure that your students are happy to join your lectures.